this week we have a very awesome presentation called Do Spruce Beetles Make Forest Fires More Severe? Field Evidence from the San Juan Mountains, Colorado, which is going to be presented by Robbie Andrus. And I'm really excited for this because bark beetles is something that I've found very interesting and often come up on my tours. So I would love to know more on this subject. So I'm very excited. And Robert Andrus is a Ph.D. student at UC Boulder right now, and the presentation we're going to be listening to is based on his master's thesis that he just finished. And he has a lot of experience, so he's spent 8 years doing forest ecology field work, specifically related to fire ecology a lot of that time. And those 8 years include 4 summers spent in North Cascades National Park, where he studied fire ecology and was a wildland firefighter. So pretty cool stuff. He has a lot of experience. I'm very excited to hear his presentation, and I hope you are too. So I'd like to introduce Robert Andrus.
All right, thank you for inviting me here. This is great. This is my first real time in Aspen, and I say first real time because I was here for a running race before, but after 36 hours of shuttling people in vans and running a little bit here and there, I was pretty delirious. So I knew I was in the mountains in Colorado, but now I'm in Aspen and enjoying it. So let me transition this over to my presentation. All right. Do spruce beetle outbreaks make forest fires more severe? So for this project, I spent most of one summer of 2014 down in the San Juan Mountains with a couple field assistants doing a lot of work in some fires that burned recently down there. It's a great spot. If you haven't been down there, it's a lot of fun. It's one of the cooler places in Colorado, I think. I did this work sort of in collaboration with my advisor, Tom Veblen, and a couple other folks in the lab that I'm working in. Okay, so if we drive into the San Juan Mountains, the eastern San Juan Mountains, we go across Wolf Creek Pass, we might see an image like this. I took this in 2013. These are a bunch of Engelmann spruce trees that were killed by the spruce beetle. And one thought that people commonly have is, oh, these trees are dead, they're dry, so maybe they might just sort of spontaneously combust, or they're much more likely to burn as a result of being dead and dry. And we see headlines such as this: West Fork Fire Complex in Colorado feeding on beetle-ravaged forests. So there's a lot of media attention surrounding bark beetle outbreaks and how fire might change when fires burn through these areas. So before we go any further, I was just curious to ask you guys what you've heard. You guys probably read the newspaper, you read other publications. So when a fire burns through a forest that's been beetle killed, how does this change how the fire burns? So do you guys have any ideas? What have you heard? Go ahead.
I've heard that the live forest actually has more combustible oils. And so, that's because I thought that beetle kill would make a forest more susceptible to combustion, but a BLM person told me that live trees are more combustible. That's what I've heard.
Okay. Interesting. I think we'll touch on that. Anything else?
Unprecedented fire behavior.
Unprecedented fire behavior. Yeah. So, having worked as a wildland firefighter for a bunch of years, I heard that a lot too. And so we'll touch on that, and we'll touch on what the study that I have done focuses on, and doesn't necessarily focus on fire behavior so much, because I can't be there on the ground when the fire is burning, because I'd rather be alive. Anything else?
They burn hotter because there's more fuel, like more dead.
Right, yeah, so that sort of goes to the point that I was mentioning about all the dry wood in the forest. Okay, cool, yeah, so these are, a lot of these things I hear too, and so I sort of hope to set the record straight on a few of these cases today. So let's take a step back. This is probably a picture you guys are all familiar with as you're driving up the valley. In our lowest elevation forest here, we have pinyon and juniper, and as we move up, we move into aspen forest. There's also some Douglas fir and lodgepole pine, but our highest elevation forest are Engelmann spruce and subalpine fir. And the subalpine fir and Engelmann spruce forest are what I'm going to be talking and focusing on today, because that's the forest type that is attacked by the spruce beetle. So we've talked about the forest we're interested in. Now let's talk about disturbances. So both of these disturbances, spruce beetle outbreaks and fire, are natural disturbances in Colorado. Spruce beetles have been attacking trees for thousands of years. There was a major outbreak documented in the Route National Forest up in northern Colorado in the 1940s. There's outbreaks that have been documented since the 1700s. And so what are spruce beetles? Here's an example of a spruce beetle. They're about the size of a grain of rice, so they're fairly small, but they burrow into the tree, and once they get inside the bark of the tree, they colonize that area between the bark and the wood. In really dry years, the trees are stressed out and they're more vulnerable because they don't have the pitch they essentially exude pitch through these holes that the bark beetles are trying to climb into. And if there's enough moisture around, they can push these bark beetles out. But when conditions are dry and warm, the trees are sort of overcome by the bark beetles. Or if there's a large population of bark beetles, they can also overcome these trees. Fires have also been really important in shaping the forest in the subalpine. You might walk through areas and you might see a dramatic change in the size of the trees. That could have been the result of an old fire. And they help to create some heterogeneity in the landscape. So we don't have just a monoculture of spruce and fir. Okay, so let's move into where are the spruce beetles affecting our forest here in Colorado. Well, we can see a couple areas. Spruce beetle is the purple here. So this is definitely one of the major areas. There's a couple areas out here through Grand Mesa and also in the northern part of Colorado. But the real big outbreak is down here in the southern part of Colorado. And if we zoom in on that area, we have South Fork here, Creed is up here, Pagosa Springs, Durango's down here. So the light purple is everything that was attacked up to 2013, and then 2014 is the dark purple. So we can see that this outbreak is expanding fairly rapidly. And this doesn't say anything about the severity or the number of trees that are killed. This is strictly, is there spruce beetle in these areas or not? Do you have a question?
When you record where these spruce beetle infections are, is it used to just like observation and mapping a point, or is there other means to do that?
So the Forest Service has a program called the Aerial Detection Survey, and they fly a plane up and down the national forest here in Colorado, and they have people in the plane mapping out where there's bark beetle outbreaks as well as all other diseases and infections in the forest. Yeah.
Can you speak to the reliability of that survey method? Some of the guys are doing this and they're like, wow, I'm trying to throw up at 120 miles an hour.
That's funny that you say that, because our lab does a lot of work with this data because it's one of the only data sets that's available. There's a lot of methods are being developed to use aerial imagery and satellite imagery to detect bark beetle outbreaks and the severity of those bark beetle outbreaks. And by severity, I mean sort of the number of trees that are killed or the area that's killed. This is presence and absence, and I think that those guys are probably pretty good with presence and absence. There might be, and by presence and absence, that means greater than some threshold of maybe 10% of the trees that are killed. So I don't know, ask your buddies and see what they say, but I think that this is the way that we commonly use it, saying there probably is bark beetle outbreak in this area, but we're not saying anything about the severity of the outbreak.
Pretty coarse.
Yeah. So this graphic, both of these are from the Colorado State Forest Service. We can see here the mountain pine beetle in the orange, and then the spruce beetle in the red. We have time here, years on our x-axis, and a y-axis we have area that's been infected. So we can see that the mountain pine beetle outbreak peaked in 2008 or so, and it's declined fairly precipitously. But we have a spruce beetle outbreak that's affecting more and more acres each year, and I think there's something like 500,000 acres that have been affected fairly recently. And whether this is going to follow a similar track to the mountain pine beetle, who's to know? But it doesn't seem like it's stopping anytime soon. Okay, so lots of folks are interested in this. We have public, the policymakers, land managers, and scientists are all interested in this topic, all for different reasons. The public commonly sees all these dead trees, and they have this idea that fire risk is going to be increased, maybe larger areas are going to be burned. They influence policy, and so there's a lot of this is sort of need to do something. So we have a lot of policy that's been put in place to fund treatment of spruce beetle outbreaks, mountain pine beetle outbreaks, reducing the risk of fire. And then land managers are in charge of a lot of the land that's been attacked by spruce beetle and where fires burn. So they're interested in how do we properly manage this land. So the large outbreak in the San Juan Mountains, it just sort of aligned for me to work on this project for my master's. There were, large-scale outbreak, and then there were some fires that occurred in 2012, 2013, and interactions of two disturbances is a fairly hot topic in ecology these days. So I looked to answer this question: how do spruce beetle outbreaks influence fire severity? So essentially the same question as my title, but in this case, we ask it in this way because there may be a positive or a negative outcome. This is a Engelmann spruce subalpine fir forest that was killed in the San Juans, not burned. We can see lots of the large diameter Engelmann spruce have been killed, and most of the green trees that you see are subalpine fir. So commonly, when a spruce beetle outbreak erupts, they attack the large diameter spruce. What's left is the smaller subalpine fir and Engelmann spruce trees. And that's what will become dominant in the years following these outbreaks. Okay, so let's talk a little bit more about these two components, that being the beetle outbreak and the fire. So how might a spruce beetle outbreak change how fire is burning? So this is going to depend on the stage of the outbreak. So how long has it been since the outbreak? So a tree is recently attacked, is going to retain its needles for a while. It's going to be a year or two before that tree actually dies and its needles fall off. Here's a pitch tube that I was mentioning earlier. We might see evidence of pitch tubes on these trees. This is where the beetle has actually bored into the tree and pitch has come out of that hole. We don't know in this case whether the beetle actually infiltrated the tree or not. So for the first couple years we see this. As the tree dies, those needles start to transition into a sort of a yellowy color, and then they fall off. And as we think about this in fire, the important point is that fire requires fuel, right? So as we lose canopy as we lose needles and twigs and whatnot from the canopy, the area that fire can burn in the forest is going to sort of change. So next we transition into the gray stage. So the needles have been lost in its gray stage because it looks gray. We still retain a lot of small twigs in the canopy. And then eventually we lose a lot of those small twigs. We're left with just the skeleton of the tree. The bark has been lost, and those trees eventually, after 50 or 100 years, fall over. And so as this is a continuum. It's not the same for every tree, but generally, this is roughly 2 years. This is 2 to 10 years, and then 15 years or so, decade after the outbreak, that's when you're seeing this. And we can see that having lost all this fuel from the canopy, that potentially, at this stage, it's unlikely that a fire would burn in that canopy. Similar to if you're going to start a fire in your wood stove and you have 3 nice sized logs, you need some kindling in there, right? You need something to ignite that fire, and you need something to ignite you need to light a match, ignite some tinder, and then eventually your large sticks in that fire will burn. If you don't have that, it's unlikely that you're going to have a canopy fire. Go ahead.
Physiological effects that cause it to fall out. Like, is it a blockage in the phloem, or what causes the needles to fall?
Yeah, so the bark beetle attacks, when enough bark beetles attack a tree, there's lots of galleries sort of surrounding that tree. If you imagine like a trunk of a tree is here, and if there's enough bark beetle outbreaks, or not enough bark beetle attacks around the tree, then it restricts movement of nutrients and moisture up and down that tree. And then eventually they're killed. Yeah. Yeah. Okay, so let's move on to the fire component. So this is a really important distinction. So as you were mentioning, firefighters commonly talk about how fire behavior is much more extreme in these areas where you have bark beetle outbreaks. And I'm not going to say that's not true today. Fire behavior deals with, what type of a fire is it? Is it a low, surface fire? Is it a crown fire? And by crown fire, I mean is the fire burning through the crown of the tree? How intense is that fire? How much fuel is on the ground, and what is the heat coming off of that fire? Those are fire behavior components. So the real-time actions of fire. What I'm interested in is fire severity. And so these are the post-fire effects on the ecosystem. So after the fire is burned, how is that ecosystem impacted by the fire? And for the sake of this conversation, I'm going to define fire severity as the number of trees killed by the fire. So there's a lot of other ways we can look at this, and I'll mention one other one in a few minutes, but I think it's fairly simple to just say it's the number of trees killed by fire. So if I say beetle severity, that's also the number of trees killed by beetle. So where do we do this research? So I've sort of led into this, but down in the eastern San Juans, we have this massive bark beetle outbreak. That's the dark gray here. Majority of this area has been attacked by spruce beetle. So any area that you see dark gray is probably spruce-fir forest. And we can see that these fires have burned through a lot of spruce-fir forest during the summers of 2012 and 2013. So the Papoose Fire, the West Fork Fire, and the Windy Pass Fire are all part of the West Fork complex that you guys maybe saw smoke from the Aspen area. I don't know if you saw it from here or not, but those were large fires, and they were burning in May, which is sort of unusual. During the winter of 2012, 2013, it was very dry. Very little snow fell. The area melted out early, and so it dried out much earlier than it usually does. So I've been down in the San Juans for a couple summers, and some summers you'll have snow that persists till early July. And these fires burned in areas that had snow that persists till early July sometimes, but in this case, that snow had probably melted out in March or April. So the forest had a decent chunk of time before the monsoon hit in July to dry out. And the other important point is that there was a series of dry lightning events. So dry lightning is lightning that is not associated with rain. And those are particularly hazardous in terms of forest fires because there's no moisture to put out that lightning strike. So in this case, these three fires for sure, and I believe the East Fork Fire up here were all ignited by those lightning events, I believe in the middle of May of 2013. And I didn't say it, but I'll just point out that this is Lake City, Creed, and South Fork. So we're in that same area that I was pointing out earlier that had the spruce beetle outbreak. Okay, so how did we actually go about answering this question? We had to be detectives of the forest, we had to be an investigator, we had to go in there, and we had to look for evidence of trees that had been killed by the fire, and also evidence of trees that had been killed by the bark beetle. So here's a common stand that we went into. The larger diameter trees here, the larger trees are Engelmann spruce, majority of which had been killed by the bark beetle. So we took our hatchets and we chipped away the bark on those trees. So when the fire burned through these areas, it commonly just sort of burned the smaller fuels and left bark on a lot of these trees. So we were able to chip that bark away, and this is the picture that we were left with. So we chipped that away, and we see these vertical galleries right here, and those are created by the spruce beetle. And get your magnifying glass out. And we can see that there is a spruce beetle right here. That spruce beetle was attacking the tree when the fire was burning. So the area had been, started to be attacked in the early 2000s. So we had sort of a varying stages of outbreak throughout the forest. So we had some trees that had been attacked 10 years previous, but a lot of them were sort of in that 5 to 6 year range. And if we chipped enough bark away around the tree, and we noticed that there was a lot of galleries in that tree, we said, we think that this was killed by the spruce beetle, even though there might be evidence of fire on that tree. And if we didn't see evidence of the spruce beetle, and the tree was still dead and it had char on it, then we said, we think that this was probably killed by the fire. Does that make sense? Yeah. Okay. So we can pass these around just as evidence. So these are essentially the chips that would have come off of this tree. So is Engelmann spruce. You can see it from the bark on the outside. If we look on the inside, we see beetle galleries. So this is sort of the evidence that we use to determine that these trees were killed by the bark beetle. So you want to check those out. Okay, so we spent a majority of the summer of 2014 working throughout the eastern San Juans looking at this. We put in 140 some different plots, and we were down there for roughly 2 months or so, working from Pagosa Springs up through South Fork into Creed. And this is what we found. We found that the spruce beetle attacked forest and the live forest burned in a very similar way. And here I have a couple pictures that don't really justify it or don't really show it that well, but the area there's very little area that had burned in live forest. So a lot of the pictures that I have are from the area around the eastern San Juans, and the East Fork Fire and the Little Sands were good examples of areas that had a lot of live forest. So without going too much into that, here we can see a forest it had burned sort of in a patchy manner, and this is the East Fork Fire, and we see a very similar setup there. So not everything is burned, but the real take home is that live forest and beetle-killed forest burned in the same way. And it didn't really matter if there was 80% of the stand had been killed or 5% of the stand. They all burned at high severity fairly frequently. So I have a couple graphs to illustrate that. Here we have spruce beetle outbreak, or the number of trees killed by spruce beetle on the x-axis, and on the y-axis we have the percentage of trees in that stand killed by the fire. And I've differentiated it here by extreme and moderate weather conditions. So the thought in the scientific community is that maybe under extreme weather conditions, that's going to overwhelm any effect of the beetle, and under more moderate conditions, that's not going to be the case. So that's why I divided it up here. So gray is moderate, and extreme is the black triangles. The difference being extreme weather conditions are dry, windy, and warmer. So, and then the moderate is somewhat opposite of that. And we would expect that if there was a relationship, we would see that as the percentage of trees that were killed by beetle increased, we would also see a percentage of trees killed by fire increase. And I don't know, what do you guys see? I mean, it seems like somebody went to the back of the room and pulled their shotgun out and blasted it, right? I mean, there's no real relationship. The one thing that really stands out to me is that we have this huge line of plots here at the top. And that means that in a lot of the stands that burned, there was high severity fire, because we're defining high severity fire by the number of trees that were killed by the fire. So a lot.
Percentage? So 100% in a stand is up at the top.
Right. Yeah. So this is 100% of the trees that remained in the stand that were alive. So we had removed all the trees that had been killed by beetle and said, of the remaining trees that are alive, what percentage of them were killed by beetle? Or sorry, killed by fire. Yeah. So I said that we would define fire severity by the number of trees killed by fire. I'll also put this up. So you remember back to the different stages, I said that the outbreak that we were working in was maybe 5 years old, so that puts it in the gray stage. So a lot of those needles and fine twigs had fallen to the ground, right? So this is percentage of the surface of the forest floor that had burned. And if we look at this, similar x-axis here, the percentage of trees killed by beetle, and then the y-axis is the percentage of the forest floor that burned. And again, we see, majority of the fires, or the majority of the stands of trees that we inventoried were all sort of up here at the top. There's, if a stand burned, it was likely that, all of the forest floor burned for the most part. And again, there's no real relationship here. There's no, we'd expect to see as spruce beetle killed trees increases, we would maybe also see a similar change in the percentage of the forest floor that burned. So then this brings us to the question, so, we have all these changes to the fuels. Why is there no change to, or how am I trying to say this? So if there's no effect from the beetles, then what is driving the forest fires to be as severe as they are and to act in the way that they are? So I have 4 components that I've come up with, and these are all commonly found in Forest Service pamphlets. These are all known as important components of why fire severity is the way that it is. So we'll start with climate and weather. As I mentioned, the winter of 2012-2013 was very dry. Things melted out. The snow melted out early. And then there was these dry lightning strikes associated with warm and dry and windy conditions. And those conditions drove the West Fork fires to burn over 70,000 acres in 6 consecutive days. So it's pretty astonishing. It's a lot of area to burn. And an acre is sort of hard to wrap your head around what an acre is. I commonly use a football field as an acre. So this is 70,000 football fields burned in 6 days. So that's a lot of forest. And the extreme weather that was present at the time of burning sort of drove this area to burn at high severity. And there's a few other reasons that I'll mention here in a second. But I bring this graph here to show that we have on the x-axis we have low, moderate, and high fire severity. So we can just think about this as a low number of trees, a moderate, and a high number of trees that were killed by the fire. And then on the y-axis we have the area. So area that was affected by these different types. So again, I divided it into extreme and moderate. And we can see there that there's one bar that's much larger than all the rest. So a vast majority of the area burned at high severity, killed lots of trees, and it occurred under extreme conditions. So this led us to believe that those conditions, those warm, dry, and windy conditions, are what drove the fire to burn a lot of acreage and at high severity. So 90% of the area burned under extreme conditions, and 80% of that area burned at high severity. And this is what that looked like. So this is from the north end of the Papoose fire. And we can see that this whole valley once was Engelmann spruce subalpine fir forest, and now is fairly denuded of anything resembling a tree. And for the most part, you can see these black stalks. Most of the trees, all the branches burned off, and they were just one blackened pole. And if we were to take a closer look, this might be what we see. We see a lot of those trees that I was mentioning, but we also do see a lot of forbs and grasses that are returning after this fire. And we can see that in here. We can see a lot of green intermixed with that black. And so we commonly think that all these trees are dying and this is this terrible thing, but there's a lot of birds, insects, and other things that like to go inhabit these communities following high severity fire. So the black-backed woodpecker is a common species in burned areas. Here's a picture of some different forbs that have colonized in the burn. This is just a year after the fire. Morels, we were lucky enough to find a few in the fires. This is aspen. Aspen commonly regenerates after fire. So within a year or so, 2 years, you might see aspen at your waist or even shoulder high. It's pretty cool. And then here's a picture of the purple plant is fireweed, and I'm not sure what the other one is, but this is also just a year after fire. So there's a lot of life, a lot of flowers that are coming back after the fire. So the next point is that the subalpine tree species are very susceptible to injury from fire. So if we look at these trees here, we can see that just the bases of these trees were burned. And Engelmann spruce and subalpine fir have very, very thin bark. So opposed to ponderosa pine or Douglas fir, which have very thick bark, and those trees can withstand fire a lot of the time, the subalpine tree species are not adapted to fire in that way. So I have a couple examples here. So this is not even very thick for ponderosa pine bark, but this is ponderosa pine bark. This is bark from Douglas fir, and then this is the same bark you guys saw when I passed it around. And this was burned, so a little bit of it lost. But the train conductor on the way out here, I took the train out here. That hasn't been mentioned, I don't think, but I took the train out here, and he wasn't willing to stop for me to cut some chunks of wood apart. So just trust me that, but you see the difference there. It's a fairly astounding difference, and which one of these do you want to protect yourself? Yeah, this one. So we can pass those around as well. Okay, so in this picture here illustrates sort of the same thing. We do have a couple large Engelmann spruce that survived the fire, but for the most part, just a little bit of burning on the roots and at the base of the tree was sufficient to kill these trees. Okay, so the next point is the fact that subalpine fir, Engelmann spruce forest have very high fuel loading. And so why do they have high fuel loading? Well, these areas have snow that persists late or early into the summer. They're very moist, they're cool, they're really high elevation. It doesn't really ever get that warm there. So fires don't occur that frequently there. And here's an example of an Engelmann spruce subalpine fir forest, and we can see that the trees are fairly close together, they're very dense. And the question commonly comes up, we hear these stories about ponderosa pine forests in the Southwest that are, park-like. This is a very, very different ecosystem. Those ponderosa pine forests dry out each spring and summer, and they have a potential to burn, any year out of, a bunch of different years, whereas the Engelmann spruce subalpine fir forests rarely dry out. So they create these very dense and thick stands of trees.
Do you see one species returning in greater numbers than the other between the subalpine and Engelmanns after fire?
After fire?
One more resilient afterwards,
Well, yes, the aspen is the sort of obvious one that if there is aspen in the area, that will usually regenerate first.
I mean, between the two conifers.
So Engelmann spruce does better at establishing in bare mineral soil, and when we say bare mineral soil, we mean areas that don't have any organic matter on them. So they preferentially colonize burned areas. Yeah. But there's also species like limber pine that are really good at colonizing areas that have burned in the subalpine. But I don't think you guys have limber pine out here too much. Yeah. We do? Yeah? Okay. So my point is that subalpine forests are dense. There's a lot of fuel. We think about, fire doesn't return to this landscape for 2, 3, 4, 500 years. A lot of fuel is accumulating. Each year, needles are falling off, branches are falling off. We have a fairly thick layer of litter and duff, organic matter on the forest floor. And that commonly leads to this sort of a picture where we have, high severity fire because of the accumulation of fuel, and we have, branches from low in the understory all the way up to the top of the tree that can carry fire into the canopy. Okay, so the next point was topography. So if we think about our landscape, especially around here in Aspen, we have very steep slopes, we have valleys, we have cliff faces, we have scree fields. So the topography is very complex. There's all these different components. There's big breaks in biomass that there's areas where nothing would be able to burn because there's nothing to burn. And so we might end up with a picture like this that's partially caused by topography. So we see here that there's forest that was not burned but was also beetle killed, and we see these different runs of the fire. So we see a big fire that ran up like this, and another one right there, but we also see this cliff band. So these cliff bands can protect the trees that are up above, and those trees aren't allowed to burn. We commonly see that as fire burns upslope, it sort of expands into this V shape. And one of the major things that we found in this fire was that as you moved upslope, the chances of a fire burning at higher severity had increased. And sort of the first principles in fire ecology and wildland firefighting will tell you that fire likes to run uphill. As fire burns uphill, it's preheating those fuels and that material up above it. So it makes it much more susceptible to burning. So here's another example of how topography can affect a forest fire. So here we see a very heavily charred area, but we also see a cliff band, and we see trees above that are still alive. So that cliff band can act as a barrier to fire in certain cases. Okay, and to sort of return to our beetle outbreak stages and recap some of our results. This study that I was looking at occurred, the time since the beetle outbreak was roughly 0 to 5 or 6 years. There was probably some trees in that stand that were much older, but for the most part it was this 5 to 6 year period, which is a period in which you have a lot of the needles that are lost from the canopy, but you also retain a lot of those fine fuels. And we found generally that fire severity, this dotted blue line here is average fire severity. We found that it really didn't change a whole lot. And my thinking behind that is that we have those other 4 factors that drove fire severity for the most part, but if we look at the canopy, there's still a lot of fuel in the canopy. So that might have also influenced the fact that may have also not changed how the fire burned a whole lot in these areas. So another study in northern Colorado in an outbreak that was roughly 50 years old, that was the outbreak that I had mentioned earlier up in the northern Rockies, studied this similar thing about 50 or so years after the outbreak, and they found that there was slightly elevated fire severity. And for the most part, this was on the ground because a lot of those trees had fallen and had created a lot of fuel on the forest floor. But there's this whole area in the middle here where we don't exactly know, what's going to happen. We can hypothesize based on the results from the work that I have been doing as well as this study, but I think it'll be interesting to see how these things change over time, and if future fires burn in the eastern San Juans, how are those fires going to burn and what's going to become of the severity. Okay, so the next point relates to what's going to happen in the future. How do we expect patterns in bark beetle outbreaks and fire to change? So this is a figure from a paper published by a postdoc that's in our lab, and he did a modeling study looking at how are bark beetle outbreaks and the frequency of the outbreaks and the area infected going to change through time. So the y-axis here is the number of trees that will be attacked, or maybe you could look at it as the area that's going to be attacked. Should be fairly similar. So the expectation is that we're going to see an increase in the amount of area infested by bark beetles because we're heading towards a future with warmer conditions, drier conditions, and this is what stresses the trees out and makes them more susceptible to bark beetle outbreaks. But at some point in time, those beetles are going to have used up all of their host tree, the Engelmann spruce, and then there's going to be a decline in the amount of area infested because there's no host left. And we can see, this is 2100, 22, this is a long time in the future. So this is what's projected. I think it's valid from the standpoint that we are entering a time of warmer and drier conditions, and there still are sufficient hosts out there. So I would expect this plays out to some degree. So what?
Where would you say we are right now on that plot?
I mean, if we're doing just based on the time scale here, this would be somewhere in here. I think that seems about right.
On the way up.
Still on the way up. Yeah. Go ahead.
Is that on data, or is it really just like a Malthusian population curve? It's kind of like the crash rebound. We often see.
It's a good question. I can give you the paper. You can read it. Go ahead.
So if snow and snowpack gets less and less, then it will change all the stats, right?
Yeah. Well, I mean, that should complement this. If we have warmer and drier conditions that melt snow out quicker, that's majority of the precipitation in these high elevation areas is falling as snow during the winter, and soil moisture, which is what the trees use to photosynthesize and so on, is coming from that soil moisture. And so if you look at a graph of soil moisture, it starts high when there's snow, and then it drops off fairly quickly. So if snow melts earlier, that's the loss of soil moisture would probably stress the trees out even more. Is that what you're trying to say? Yeah, okay.
I'm trying to say that maybe the forest won't make.
Yeah. I think that's possible. I mean, I wouldn't say that the forest won't make it. I would say that there's going to be an increase in spruce beetle outbreaks. There might be an increase in seedling death and so on. But
And one more point, I live in Missouri Heights, and I've noticed over the last 20 years that when I walk out onto my front lawn in the wintertime, I can feel the heat-forced air. It doesn't feel like the air 20 years ago when I moved here. And it's like you can feel the colorless, odorless, invisible gases that are percolating in all the extraction wells around us. You can feel it in the air, even if you can't see it without infrared.
yeah, well, that's not something I can speak to, but I trust you. So let's talk about fire. So as this is a figure from the last, say, 15, 20, I guess it's more than that. I guess it would be 25 years. We can see that the number of large fires in the Rocky Mountains have increased. And this is a result of warmer and drier conditions. And here's a projection for the future. This goes from current to 2070. And this is looking at the relative change in the number of large wildfires. So as you get redder, it's saying there's going to be a greater increase in the number of large wildfires. So we can see here in Colorado that we're not nearly as bad as places in the northern Rockies, but we're definitely going to see an increase in the number of wildfires, large wildfires.
Does that account for the more fires you have, the more heterogeneity you're going to have in the landscape?
Right.
The less ability to carry fire is going to be present, so that would be a suppressing force.
Right. Yeah. Yeah, that's a really good point. And what I would say to that is that the area that's burned by fires in these areas, in comparison to the area that is habitated by trees, is fairly small. So if we look at all the area that's forest in Colorado, and we look at all the area that's burned, that burned area is fairly small in comparison to the whole of all the forests. Okay, so a couple take-home messages. So I looked at the gray stage spruce beetle outbreak, and we found that did not increase fire severity. It didn't increase the number of trees that were killed. It didn't increase the amount of charring on the surface. And we found that these other factors, like weather and climate, the high fuel loading in spruce-fir forests, led to high severity fire. Also topography and the susceptibility of those trees to injury were really what drove the high severity fire in this ecosystem. And as we just went over, warmer and drier conditions will likely lead to trees that are more stressed out and an increase in bark beetle outbreaks in the near future, and also an increase in fire. So I thought I would end with this picture. This is a picture from the West Fork complex. And there's a lot of anecdotal evidence from firefighters on that fire and talking about how they had used aspen as a natural fire break. So here we have a sea of burned conifers, and then we have this patch of aspen that we can see was burned into, but it wasn't fully burned. And if you were to go back to this spot, in the summer, at some point in time this next summer, we would probably see aspen that have rebounded to waist or even shoulder high in these areas surrounding that patch of aspen. So I thought that was a pretty cool picture. All right, and with that, yeah, if you guys have any additional questions.
So for the rest of the questions, which we do have a couple minutes for, I'd like to pass this mic around. I know it doesn't amplify your voice, but we do use it for the recording. So I will come around with the microphone to those of you who have questions.
In Science magazine, there's a big forest study of European forests.
Mm-hmm.
And they've been doing forest management for some time, and it was a study from the 1750s all the way to today.
Okay.
And they replaced a lot of their deciduous forests with conifers.
Uh-huh.
And it was a study on CO2 sinks and, absorbing CO2. And the study found out that the evergreens don't do such a good job.
Okay.
So,
yeah.
So what does that have to say about this process that you're studying?
Well, I didn't study CO2. I mean, yes, CO2 is lost
I mean, the loss of evergreens to beetles and fire. And in Europe, the opposite was happening in their forest management.
Okay. I think I understand the question to some degree. I mean, yes, we have lots of dead trees, and to some degree, we're going to lose some CO2. I think it's an area that is a hot topic right now in the forest community, and we're going to see a lot of work published in the next 5 to 10 years surrounding, how are bark beetle outbreaks and fire changing our carbon stocks. So I think that there's a lot of unknown questions in that area.
Are there any other questions?
Thanks a lot. I know that a lot of us naturalists, I work at ACES, and this is something we all talk about in our tours, but we aren't. I feel like a lot of us don't have an expert to talk to, so it's great that you came, because we now have.
Yeah,
I feel like
happy
a lot
to be
of our
here.
information is now supported. I'm curious about whether or not. So it kind of seems like the interesting part about the fact that beetles kill trees is that the trees are dead, and that the trees there are a lot of dead trees.
Right.
And I'm wondering if there's if there's any other reason why there'd be lots of dead trees in a place, and whether or not you can use that as like an analog to study beetles. Like if you don't, can you go to another forest where maybe there was a drought and all these trees died, and then you can study how fire has changed those forests, or is there something unique about beetles?
Yeah, and so you're getting at this point exactly. That for us, it didn't really matter if the beetles had killed a tree or they had been killed previously. They were the same. We sort of treated them the same. If they had been sort of killed in that same time span, if they had been killed, say, within the last 5 to 10 years, we included that in our category of killed by beetle, because we were just really looking for the number of trees that had died recently. So, so I think it definitely can answer that question as well.
So it's sort of a dead standing tree question?
Yeah.
Okay.
Yeah. You gonna fight over it?
If you were gonna make a hypothesis about that time frame where the gray trees have lost all their needles but not yet fallen to the ground, what would that hypothesis be?
We should do the research in 15 years. No, I mean I don't think it's going to change. My guess is that we're not going to see a whole lot of change, because the things that are driving these fires are climate and topography and these other factors. But I think it's definitely an unanswered question. We need to wait and see. You guys had the same question?
Second round.
Just coming back to the question that you started maybe your whole research project from, is this driving greater fire severity?
Yeah.
It seems like there's a lot of wacko ideas out there, like especially in Summit County that I hear about, removing standing dead beetle kill, talking like hundreds of miles of forest.
Yeah.
And it has always seemed like there's a disconnect between the science and the policy of forest fighting at the U.S. FS level.
Yeah.
Are you having to like advocate for your results to let people know that maybe there's a disconnect or a discord between what the media has been reporting versus what the science is showing?
Yeah. So this paper, when I published my master's thesis, it got a decent amount of press. I mean, it was folks in San Juan Mountains, and it was covered in a Summit County newspaper of some sort. And we actually, without me asking the Forest Service to comment on it, or without me like pushing on it, some folks from the Forest Service did approach me, and they said they'd found the paper and that they were very happy that I had published this work, and that they were going to include it in some report that they were going to publish. So they know about it, and it seems like they understand it. And it doesn't seem like, I understand the disconnect that you're talking about, but it seems like with this study in particular that they've done a pretty good job of reading the literature and knowing that this paper exists and incorporating that into their management practices. But I do know that there's a lot of logging that's occurring in the Grand Mesa area or proposed for the Grand Mesa to mitigate fire risk because of all these bark beetle outbreaks. And I guess my response to that would be that, we did this study and you guys, I told you what we found. So that would be my suggestion to them. Managers have to consider a lot of different things. So we'll just leave it at that.
Yeah, there's a 120,000 acre cut planned for the Grand Mesa and Pography National Forest.
Yeah.
That they're in the final stages of wrapping up their decision document on.
Yeah.
Which ignores this.
Yeah.
Is it called salvage logging? Are they trying to get dead standing timber in?
Some of it's salvage, but some of it is trying to get ahead, trying to log in front of the beetle, and then trying to reduce fire risk to the forest.
Mm-hmm.
But the cynical interpretation is there's a big mill in Montrose that a lot of people are invested in keeping operational.
Tintin supports that.
Yes.
Pretty aggressively.
All right, I think we'll do our last question. Anyone else have one? I guess everyone's so timid.
Yeah, I can ask.
So, I've done a lot of work in the mountain pine beetle, lodgepole affected forest, and there's kind of a consensus that the fire risk during the red needle stage, which is after the tree's dead, the needles are still on the tree, the risk goes up.
Right.
And then when the needles fall off, the risk goes down significantly below baseline green forest level. And I was expecting you to have the same conclusion in this, but it sounds like it's different for spruce.
I would say not different. The expectation that you're talking about has not, if we look, this study that I've done is replicate of several studies that were done in the northern Rockies on lodgepole pine. And they essentially found the same thing, that high elevation forests like this need the right climate and weather to burn, and the trees are susceptible. So we have, this is your classic blue stained lodgepole pine, and we can see the size of the bark on there. It's fairly thin as well. So these trees are going to die if they get hit by fire. And yes, I think that the literature has found that these red needles or the yellow needles in the case of the spruce are more flammable because they've lost a lot of the moisture and their foliar chemistry is changing. But that's it's like a 2-year period. It's a very, very short period of time. And if we need the right climatic events to align with that, I mean, what are the chances of that? I mean, it's pretty small.
And
so,
it hasn't happened in Summit County.
yeah, I mean, yeah, how much of Summit County is burned following the, yeah.
Right.
So, yeah.
All right, so if you have any more questions, feel free to stick around and ask afterwards. Otherwise, thank you so much for coming. We hope to see you next week. And let's get another round of applause.